Hi everyone, let's solve this Leetcode problem. So basically we have to find the longest substring without repeating characters. So let's read the problem. You are given a string S and we need to find the length of the longest substring without duplicate characters. So for example, we have this input string S and the output is 3 because the answer is ABC with the length of 3. If we go beyond ABC, the character A gets repeated again, and beyond which all the characters get repeated. So the longest substring without duplicate characters is of length 3. And if we see the second example, the answer is output is 1. Let's try to understand this problem now. Okay, so basically if you look here, I have basically added a string S here, and our aim is to find the longest possible substring without duplicate characters. So let's solve this problem first with brute force approach and then we'll optimize it. So if you were to solve this problem by brute force approach, what will be our idea be here? So let's have two variables I and j, which initially they point to the same character, which is at 0th index. Now we'll keep I as fixed and we'll iterate with j updating by 1. So initially I and j both point to 0th index. Now we are going to increment the j, and j instead of pointing here will point here. Now we've incremented j, right? Now what we'll do is we will have a boolean array with us, right? So let's have a boolean array with us, and the boolean array, the length of this boolean array is 128 characters. Because 128, because if you were to normally go by any alphanumeric characters, within 128 you can have all the characters. If let's say for instance we have capital A, its ASCII value is 65, capital B is 66, small a is 97, and so on and so forth, right? So the starting index is 0th index and the last index is 127th index. Okay, now what we'll be doing is that this is a boolean array, right? So let's say we have an index with 65. That's where capital A, the boolean value will be stored. So initially all will be marked as false, right? Now from this particular string we'll pick up small p. Let's say it might come, let's say here, it's the index would be the corresponding ASCII value. So small p is here. Now initially it is marked as false, but now when it sees p, we're going to change that from false and we will mark it as true. Okay, so now this, for instance, we will mark this as true, right? Okay, and then we have w. Let's say w is here. Initially it is false, but now we have marked it as true, and we're going to increment j. J will come here, and w. In this array, boolean array, we're going to see that w is already marked with true. So we're going to return within this particular substring, from this I index to this j index, are there any repeating characters? And the answer is yes. So we will return false, that this is not this is not the longest possible substring without any repeating characters. This will return it as false. Now what we'll do is that we're going to have a max integer array, okay, and its length will keep on updating. If its length is initially 0, but now when j comes to this index, the length would be increased, right? So accordingly we will increase the the maximum length. And if we notice that any character has a repeating like any of the string elements has a repeating character, what we will simply do is that we will simply return from this particular function, if we have a separate function to calculate if the existing string value from I index to j index is any of the repeating characters are there, we're going to simply return false. And if we're going to return false, then what we're going to do, the maximum length won't be incremented, and simply we're going to just increment uh, in uh, in that case the having a longest, this thing would not make any sense, longest character sequence. So in that case we would have to increment I. So I mean, if we were to go by brute force, we'll have to maintain two loops, for one for I, one for j, and iterate through them. So that is too much of okay that is too much of what do we say, in terms of time complexity, it will be O of n square, because two loops we are running parallelly. But if you were to solve this by some optimized approach, we have a sliding window or a two pointer approach, right? So let's understand the two pointer approach that we might apply in this problem. So if we were to solve by two pointer approach, what we'll do is that we have this okay, let's solve by two pointer approach, right? So we have this string s with us. Let's quickly copy the string s, right? Yes, so this is s and the string is p w w k e w x p w. Okay, now basically what we have to do is that we have to make sure, using two pointer approach, we have to solve this problem. So essentially in two pointer approach, what we'll be doing is that we will again start with I here and j here, and here we're going to increment basically what we'll be doing is that we're going to see. So like we don't want any duplicate characters here, so we have a data structure which we have basically hash set, a set which comes from the set interface. So hash set is a class which comes from set interface, and set interface in terms it in turn it comes from the collection interface or the collection framework. Okay, fine. So if you want to solve this problem, what we will be doing is that we're going to first initialize I and j to the same pointer, and let's say we have a hash set with us, right? Which will so hash set, it doesn't store any duplicate elements, only unique elements are stored, and it is an unordered collection. There is no ordering of unless how we have an array is an array list, they're stored in some order, specific order of insertion, but in sets it's unordered collection, right? So basically what we'll be doing is that we're going to check if p exists in the hash set or not. Okay, so p doesn't exist in the hash set, so we're going to add it in the hash set, and then we're going to move the and then we're going to move the j index. Now j will point here, and we're going to see if j exists, if w it exists in the hash set or not, if it contains in the hash set or not, and the answer is no, it doesn't. So let's add w in our hash set. Now we're going to increment the j pointer again, and we're going to reach this index. We have j here, and now we're going to check if w it contains or exists in our hash set, and the answer is yes. So we can't have a longest substring with this combination, and the reason is because it contains duplicate characters, and the duplicate character that we have is w here. So in that case what we will be doing is that we don't want this particular sequence. So we will basically want to have such mechanism in such a way that the duplicacy gets removed. So what in that case we're going to do is that we are going to increment the p pointer, right? Because the I pointer basically, not the P pointer. The P is the index. At that particular index the element is present. We're going to increment the I pointer. Abhi I will point here. So first we're going to remove this, and once this is removed, so what we're going to do, we're going to check if P, so we're going to remove the P element from this thing. So we can call this as left, and we can call this as right, or I and J, whatever we prefer to. So we're going to check if we're going to remove P, so P is removed from here. We only have W, and we're going to check if W exists in the hash set. Yes, it exists already. So we are going to increment the I pointer. Now I, instead of pointing here, it is going to point here. Right? So this W would be removed. And once this W is removed, then we only have, then what we'll be doing is that we're going to check if this W exists or not. It's removed. So we can add W in the hash set. And then we are going to increment the J pointer now. Let's change the marker color, and we're going to increment the J pointer. Now J, instead of pointing to W's index, in the index where this thing exists, it will point here. This is where the J will point. And we're going to check if K it contains in the hash set. No, we're going to add it, and we're going to increment this J pointer as well. Similarly, E, we're going to see if it exists. No, we're going to add it. And once we come to W, this particular index where J is pointing now, we're going to see if W exists in our hash set. Oh yes, it exists in our hash set. So what we're going to do is that I is pointing here, right? So we basically we can't have this particular substring. So for that reason we have to remove I. So I we have to remove. That means W would be removed from the hash set. Yes. Okay. Once W is removed from the hash set, then we are going to have okay, and the index of I is going to, and the index of I is going to change to K. So let's change it and make the I here. Now we will check if I exists here or not. Oh yes, I exists in the hash set. So the ith index, the K value exists in the hash set. Oh yes, it exists in the hash set. So what we're going to do is that we are going to remove K, and we're going to increment the I pointer. So now I is going to point here, right? And once we have removed K, on the similar lines we're going to remove E, and we're going to remove E and increase the ith pointer. So I is going to point, okay, let's have this. So I will be pointing here, okay, and we're going to check if W exists or not. No, so W doesn't exist, so we're going to add W. Okay, but here we have forgotten to keep track of max variable. We have to actually keep a track of the max variable that we are just solving it, but nowhere we have kept track of the max variable. So earlier, if you see here, when we had KEW, the max length was 3, right? This was the max length when we were looking at this particular thing, and so far it has not been updated. I and J have moved here, max pointer has moved here. Now what we will be doing is that now we have W added, and we're going to add X also, and we will be adding P also, and by the time J would have been moved here, time J would have been moved here. KW when you had KEW, the length was 3, right? The length was 3. When the length was 3, then W. Okay, I think we're making some mistake here. Let's redo this quickly. Let's redo this very quickly. Okay, so for this purpose, what we'll be doing is that let's have a max variable initialized to 0 initially. So we have a hash set where we're going to store all the elements. Okay, so first add P, then add W. I is pointing here. J, when it notices that W already added, then we're going to remove P. So the length would have become 2 by now. The length becomes 2 by now, right? Because P and W are added. And by the time it realizes W already exists in the hash set, so P is removed, I is incremented and moved to W. And we realize that W already exists, so we're going to remove W and we're going to point I and J to this particular index. Now this particular index I and J are pointing, and we have removed both of them, so we'll make sure now we'll add W to the hash set. And once W is added hash set, the max values are compared. So still 2 is fine, is greater. This is 2 basically, right? Okay. Now W is added here. Now what we will do is that now we have KEWX. So what we'll be doing is we will increment quickly K and E. So if you see here, J has moved, I is still at W, I is still here, and J has moved here. And by the time it has moved here, the length has become 3, because this thing, the index is the length has upgraded to 3, right? This is 3. Okay, now J has moved here, and we notice that W already exists. So what we'll be doing is that ye wala left pointer we're going to remove from the hash set. So this one will be removed from the hash set, and K already exists, remove K from the hash set. E already exists, so remove E from the hash set. Okay, and the length is still 3, and W doesn't exist, I and J pointing on the same index. Add W to the hash set. Okay, now what we will do is that right. KEWXP. No, but then if you see here, this would be the longest substring because there are no repeating characters. So the length till it iterates here would be 4, and that is what we intend to find. By the time it reaches here, so anyways they would be removed, but the length would still remain the same. So that is the essence that we have to solve this problem. So let's code this problem up on our Leetcode. So for that purpose, let's have 2 pointers. Int left is equal to 0 and right is equal to 0, and let's say max length is equal to 0 again. So we're going to have an outer loop which will basically move the right pointer initially to its initialized to 0. It will move till the s dot length length function. Okay, and we'll increment the right pointer now. So what we'll do, we'll get the first element. Let's initialize a hash set. So from set, let's take a set of character. Let's call it as ch is equal to new hash hash set. So this is the implementation class for set interface. Okay, now what we'll do, we'll make sure that whatever character we have, we're going to add it to the hash set. Can you please close the door? Yeah, and we're going to add ch dot s dot caret. We're going to make it s dot caret right. We're going to add it to the hash set. So once this is added, then what we will do, we'll keep on iterating. But if we get a repeating character, like how we had gotten earlier, so if we get a repeating character, so we're going to have a, let's say, a while loop, which will make sure that which will keep on iterating till basically in the string. So what we will do is that let's put this one above it, right? So this is the initialization, so let's not add it here, let's put it here. Okay, now while, as long as ch dot contains, in the hash set, if you have s dot caret right, as long as the right character exists in the hash set, we're going to remove the left one, right? So ch dot, I'm recording here, can you please be a little mindful of the fact that I'm recording here? Ch dot remove, so we're going to remove the left one, s dot caret left, and once the left character is removed, we'll be incrementing the left pointer, right? Okay, so we're going to increment the left pointer. We even have a max variable, right? Okay, so we even have a max variable such that it will give math dot max of your basically okay, so once we're going to add that max here, after we're adding it, so let's say max is equal to math dot max, the max of max comma the substring length, which is right minus left plus 1, right? So let's actually try to run this code and see what we have. There is a compilation error, int right is equal to 0 already defined. Okay, so let's not define it here, let's make it this way. Int, okay, so basically we already defined it, right? So let's make it this. Yes, now I think we should be good. And line number 22. Okay, so we have to return, right? So that's the whole idea behind returning the max length. So here we will make a return call and return max. So let's do that quickly. Okay, so all test cases are passed. Let me submit this problem. Okay, so we have successfully submitted this particular problem, and yeah, that was it. So this was the explanation, and hope you liked it.